Hello everyone. This research is about impact of randomness on delay and oversaturation in shared left-turn lane. We have realized that the signalized intersection strongly impact the performance of urban road. Randomness of the vehicle arrival with another randomness of opportunity of interruption caused by crossing pedestrian in the shared left-turn lane affects the performance of the road intersection. From this simulation result, we found that the randomness decreased the average capacity, which varied largely during each cycle. In addition, sometimes the oversaturation occurs even at a lower demand than the average capacity, which cannot be anticipated by current performance evaluation method. This shows the importance of considering the randomness for signalized intersection design and the possible necessity of the real-time intelligent signal control scheme for a better operational performance. Now, let's see in detail, starting from the introduction. As shown in figure A and B, shared left-turn lanes are typically operated under the permitted phase with an adjacent pedestrian crosswalk in Japan. That means there will be green light for left-turn vehicle and adjacent pedestrian at the same time. So the left-turn vehicles are disturbed by the pedestrian, which blocks the following thorough vehicle in this lane. The position of left-turn vehicle affects the operation. For example, if the left-turn vehicle is in the front, it blocks all following vehicles, while if there is no such vehicle, the thorough vehicle can pass freely. So the random arrival of such vehicles affects the performance of the intersection. The existing studies only evaluates the average performance, while the randomness of left-turn vehicle largely affects the performance in each cycle. The objective of this study is to analyze the variation due to randomness on delay and oversaturation in shared lane and understand issues in existing evaluation method. For the randomness of vehicle, Monte Carlo simulation is used, where the left vehicle arrives randomly based on left turn proportion. The green time is divided into two stages. In stage 1, pedestrian blocks completely the left-turn vehicles and through vehicle can pass until left-turn vehicle is blocked. In stage 2, there are no pedestrians, so all vehicle can pass freely. Since the left-turn vehicle has to deaccelerate during turning maneuver, different departure saturation headway and startup delay for left-turn and thorough vehicle is assigned based on their position. Now, if we see the result, in case of a shared left-turn lane without exclusive through lane as shown in figure A, we can see the simulated average capacity is smaller than the estimation done by JST, which means the existing method have overestimated the capacity. And if we see the variation, the capacity vary largely when the left-turn proportion is small. Let's see the delay and saturation at left-turn proportion of 0.2. The average delay is increased and variation is significant when the randomness is considered. At higher flow ratio, the variation is higher. Similarly, more vehicle remains uncleared in each cycle when randomness is considered. Now we see such effect in left-turn lane with exclusive through lane. We have considered two different conditions. In type 1 lane, it has one shared left-turn lane and one exclusive through lane. And in type 2 lane, it has one separate dedicated left-turn lane and one dedicated through lane. For type 1, we can see larger delay and its variation occurs in shared left-turn lane and higher number of vehicles remains uncleared at this lane even at low demand. For type 2, it has only a slightly larger delay with almost similar variation in through lane and in exclusive left-turn lane only at higher demand. So in conclusion, we see that in a shared left-turn lane, due to the randomness, traffic capacity varies by cycle, delay distributes largely, and oversaturation occurs even when demand is smaller than the average capacity. With a dedicated left-turn lane, delay in through lane is slightly higher at higher demand only with smaller variation. In future, this result may need to verify with actual data collection and analysis. That's all about the summary of this result. Thank you very much for listening. Thank you.